To generate the lists of materials, it is necessary in DRAINS to define the fittings, such as Ys and Ts, among others, available sizes on the market for the type of pipe we are using in the design of the storm and sanitary drains in buildings. In this video, using plumbing stacks as an example, specifically a soil stack, we want to show you the steps to follow to achieve the proper accounting for fittings. It is worth noting that the considerations explained here for the waste stack are entirely applicable to all other components, such as sanitary branches and sewers, among others, of the building's drainage system that you are designing in the program. We will use, as an example, one of the sanitary stack pipes available in the multi-family housing project that we already know. Specifically, the soil stack number 2, the one collecting the sewage from the typical drainage network 2, in each of the 4 levels of the building. In this case, as you see here in the stacks branches table, the automatic calculation has defined the diameter of 110 mm for it. This diameter, as you know, is defined by one of 2 conditions: the total number of fixture units conveyed by the soil stack, or the inflowing sanitary network's diameter into the soil stack. Here it is very sure that it is the latter case that has predominated, since we see that drainage network 2 discharges into the waste stack with a diameter of 110 mm. Surely, also set by the existence of the toilet at this point. Anyway, if we go to the material list of our soil stack, we have 5 Ys, 5 elbows, and a cleanout cover in the referred diameter. Note that 4 of these elbow Y sets are included to allow the incorporation of the 4 horizontal branches at each building's level, while the 5th is the one that allows the stack's cleanout conformation at its base. Everything is in order regarding fittings quantities in this case. Now, let's suppose that the resulting diameter in the waste stack is not 110 mm, but 160 mm. I will modify each of the branches of the stack to this value. I recalculate the project, only to ensure that the modified sizes in the file are updated. Go back to the list of materials. We see that the Ys and the cleanout cover disappear, remaining the 4 110 mm elbows necessary for the change of direction of the horizontal branches of each tributary network to the sanitary stack. So, where are the missing fittings? In this case, the accounting has not been carried out properly because the project file does not include, in its fittings list, the Ys and caps of the necessary diameter, which, remember, we are setting at 160 mm. Let's see how we determine this. I go to Configuration and hit the button under Fittings. It is assumed that the sizes of each of these fittings are those that are commercially available to carry out our project. If we look at the existing diameters for the Ys, we see that there are none with a main diameter of 160, but there are that of 110 mm. And, if we think about the reduced ones, we also do not have the size set for the soil stack. In the same situation, is the cleanout cover. Exist in 110 but not in 160 mm. So the solution here is, first, make sure that, for the soil stack's resulting diameter, the corresponding fittings are available. Once this availability is confirmed, what remains is to add the sizes to each type of fitting. Then I add a 160 mm Y, used to conform the waste stack's cleanout. A reduced Y of 160 by 110 mm. To receive the drainage networks on each level. And finally, the cleanup cover. With the new fittings loaded, I hit OK to update. Returning to the sanitary stacks list of materials. Now, finally, the necessary fittings are adequately included in our design. A cleanup cover with its respective 160Y. And 4 reduced Ys with the corresponding 45-degree elbows to receive the drainage networks. So keep this in mind for your next projects with drains.